So now that we've talked a bit about concurrent collections and I gave you a quick overview of what a concurrent hash map was, we're going to talk about how to apply concurrent hash maps to design a very interesting reusable class called a memoizer. And as we'll see, a memoizer is a data structure that caches the results of function calls, especially long-running function calls, and returns the cache results when someone gives the same input. So basically, it's a cache, and it's a memoizing cache. So memoization is a technique that's used to speed up programs. People sometimes misspell this as memorization. In fact, it's hilarious. The term is memoize. You can go look memoization up. But if you read the, I think it's the Java Concurrency in Practice book, which is one of the classics in the field, whoever proofread it probably thought, why are they misspelling memorization? So they changed it to memorization, which is not really what it's doing, although it is kind of memorizing the results. So the basic idea is to take long-running function calls and cache the results of those calls. So if you kind of think about how compute if absent works, you go ahead and perform a long-running computation and associate it with a key and store the resulting value via the key, if the key is not already there. And then you return the value associated with the key. And that way, if someone comes along and gives you the same key, rather than reperforming that long-running computation, you just give back the previous results. So that's really, in a sense, that's what caching is all about, right? I mean, there's different kinds of caching, but that's the basic idea. Rather than recomputing something, you store it and then hand it back when somebody asks you for that same thing again. So we're going to use this memoization technique to define a cache that returns a value produced by applying a typically long-running function and associating it with a key in the map. And we're going to do some kind of cool things that go above and beyond what's in the classic Java Concurrency in Practice book by Brian Getz et al., which is a great book. It's a little bit old, but still got a lot of great insights about how to write concurrent and synchronized programs. And so basically what we're going to do here is we're going to have a class called the memoizer, which is a generic class, so it's parameterized by key and value, by k and v. And we're going to go ahead and have this thing implement the function interface. And I'll talk a bit more about that in a second, why we do that. We do that so we can use the memoizer anywhere you would expect a function to be used. So it's going to be a kind of a transparent optimization technique. So what you do is the memoizer is basically passed a function and a map, and it will go ahead and use the map to check to see whether or not we've already got a value for a key. And if we do not, we apply that function the first time, cache the results, and then next time someone comes along and asks for the same key, we just give back the results. Since we inherit from, or rather we implement the functional interface, then we can use the memoizer any place a function is expected. So if you have code that expects a function, we can transparently kind of interpose the memoizer. And because it implements function, it implements the apply method, which is the functional interface method that we have on function. Internally, the memoizer uses the concurrent hash map to minimize synchronization overhead, and of course also to store the results. That's how we're going to cache the results. As we talked about before, concurrent hash map is clever because it uses these segment locks so that there's less contention on the state of the concurrent hash map if multiple threads come along and try to access it, either putting or getting things from the map at the same time. Under the hood, the apply method that is defined by the memoizer uses the compute if absent atomic check then act method on concurrent hash map. So this basically ensures that a function is only run once whenever a key value pair is first added to the memoization cache. And so this is basically what it looks like. So as we'll see when we look at the implementation here in a second, the code under the hood, when we call apply, will turn around and say compute if absent passing in the key and the value. And then under the hood, that's essentially optimized to be something that will apply the function and then update the map if we don't get a null result back. And the cool thing about this is you could have multiple threads simultaneously trying to call compute_if_absent, and that function only gets run one time. That's kind of the secret sauce of the compute_if_absent method. Okay, so that's kind of a high-level overview of what the memoizer does. In a second, we'll look at the detailed implementation, and you'll see how it uses these features under the hood.